Hello, geometry. Welcome to lesson 2 of unit 9. We're going to start getting into some area here. Areas of triangles and parallelograms. Not too difficult, probably. So you've probably seen most of these theorems before, not most of these formulas, I guess, not theorems. The area of a parallelogram is simply base times height. Okay. The base of a parallelogram can be any side of the parallelogram, but each side has a corresponding altitude. Now, the altitude and the height are very, very, very similar. The altitude is the line, and the length of the line, or the length of the altitude, is the height. So we basically think that they're synonymous. They mean the same thing. They're not technically the same thing, but it's very, very close. So that red line there, that's going through the middle of the parallelogram, is the altitude, and the length of that line is the height. All right, so go ahead and clear that. Scroll down a little bit. I'll answer a few questions about that. So in this parallelogram, which lengths could represent the base? Well, it could be any side of the parallelogram. So I could have 2 or the 2.5. Those could be the bases, either one of them. Which one would make sense to use in this problem? Well, I'm going to tell you that the 2.5 makes sense to use. Why? We use this base because we are given the corresponding altitude. Okay, and that's the 1.8. We know that that's the corresponding altitude because of the right angle symbol. The altitude must be perpendicular to the base, or the height must be perpendicular to the base. All right, so a lot of people are going to say 2 times 1.8. That is not accurate here. So with the base being 2.5 and the height being 1.8, I just multiply those together, and I get, I believe it's 4.5. Yeah, 4.5. So the area of this is 4.5 meters squared. Now, what is the altitude associated with the other base? The other base being the 2. Well, I'm going to draw in here an altitude. It's got to be perpendicular, so I'm just going to do the best I can. Okay, I'm looking for the length of that piece right there. How am I going to find that? Well, the area of this figure is not changing. The area has stayed 4.5. So I'm going to put 4.5 in for the area. I'm using the other base, which is B, B, which is 2, and I'm looking for the corresponding height to that base. Divide by 2, and I get 2.25 for the other altitude. So the line, that dotted line going across, is a little bit longer, which makes sense because the area has to multiply to give me 4.5. Right. So there's one example. Got a couple more here. The first two are pretty straightforward. On the back, we start using what we did last lesson. So this first one here, a lot of people look at that and think, oh, I need to figure out this piece right here so I can get that whole length from here to here. Well, good news is you don't need that. Okay, I don't need the length of that. The length of the base is either 2 or 4.6. Well, because of the right angle here, I know that the side that's perpendicular to that is the side I want to use. So that would be the 2. So my base here is 2. My height is the side that's perpendicular to it. Now, the side does not have to go through the middle of the parallelogram. It can be on the outside like this one here. From the top to the bottom of that parallelogram is 3.5 centimeters. So the area is just 2 times 3.5, which is 7. And always remember to put the label centimeters squared. Number 2, FC is 10 inches. So I'm going to put a 10 here. I look for those right angles. I have a right angle here, but I don't know this side or this side. So that base, or so that height of 12 does not have a good base with it because I don't know what those are. So I'm not going to use that one. Rather, I know that this is 13 and that this side is perpendicular to it. So I'm going to use my base of 13, and my height is 10. Multiply those two numbers together, I get 130 inches squared. Okay, it's just a matter of picking out what the important pieces are. Now on the back, it gets a little trickier. Make it a little bigger for us here. So I see a 60-degree angle. I see the 8 and the 12. Those are both, either one of those could be a base. I'm going to drop a dotted line here, and that's going to be my altitude. So that's going to be my height. If I look at that, do you see how I made a 30, 60, 90 triangle? So that's a 90 here. I already got 60, so this is my 30. So if I'm looking at that triangle, only that triangle, what do I know in that triangle? A lot of people are going to put the 12 in there. I don't know 12. A lot of people are going to cut that 12 in half and say 6 and 6. I don't know that that altitude cut that in half. I don't know any of that. What I do know is the hypotenuse is 8. That hypotenuse is fully in that triangle. Okay. Before I go any further, I'm going to go up to the top here. This is something you're going to see me do in this unit. We have a lot of formulas coming. I don't want to do too much, or I want to make sure I do enough. So I'm going to put the two things that I need to find the area. For this problem, it's a parallelogram. I need the base and I need the height. I have two bases, but I'm not sure which one I want to use yet. Actually, I am now, but and then I don't know the height yet. Once I get what I want, I'm going to put those numbers next to those things there. When I have numbers for B and H, don't go any further. Multiply them and move on. Okay. So back to the 30, 60, 90 triangle. I know the hypotenuse is 8. Hopefully we're comfortable with these right now. The short leg is half the hypotenuse. So the short leg is 4, which means the long leg, or the height in this problem, is 4 radical 3. So my height is 4 radical 3. And then the base is the one that's perpendicular to 4 radical 3. So it's going to be 12. Multiply those two things together. I get 12 times 4 radical 3, which is 48 radical 3 meters squared. Okay. Next one, I got a 135-degree angle. I've got 8 and 4, very similar. I got two bases. I don't really have a special right triangle with 135, but watch what happens here. I'm going to draw that to be a right angle and a right angle here. 135 degrees, and I have 90 right there. What's left on this angle is 45. 135 minus 90 is 45. So now I've got a 45, 45, 90 triangle. I know it doesn't look like it, but it is. Now, what do I know in there? Well, I see this 4 here. Since it's a parallelogram, I know that the opposite sides are congruent, so this is 4. Stay consistent here. The base and the height are the two things I need again. The base that I'm going to be looking at, here's my right angle, so I'm going to be using the base of 8. I'm going to use the 4 to find the height, which that and that are equal. So the hypotenuse is 4. We're looking for the leg, call it x, and then it's square root of 2 times x, so we're going to divide by radical 2. So 4 radical 2 over 2, which reduces to 2 radical 2. That's the height. Now I'm going to multiply those two things together. I'm going to get 16 radical 2. There's no label, so I'm going to write units squared. Okay. All right, so that's parallelograms. Okay. Now we're moving on to triangles, which are very, very closely related to parallelograms because they are half base times height. So instead of base times height, it's 1/2 base times height, or you might see it as base times height divided by 2. Okay, why the 1/2? Every single triangle is half of a parallelogram. Some of you might already known that, but it is. Any triangle, if you basically double it, like flip it, you're going to get a parallelogram. So I'll just draw a parallelogram real quick. I cut it in half, see what you get, a triangle. So basically I'm cutting out half of the parallelogram when I'm finding the area of a triangle, where the 1/2 comes from. Okay. Just like in a parallelogram, the base can be any side of the triangle. And the height or altitude must be perpendicular to the base. Okay. So we're basically doing the exact same stuff we've been doing. The only thing you have to remember to do at the end is divide by 2. Find the area of each triangle. I gave you more information than you needed on this one, but I want you being able to sift through and find what's the important stuff. I still need my base. I still need the height. But the only thing I got to remember is at the end or sometime in there, I have to do 1/2 of that. Well, if I look at this, 6, 12, or 14 could be my base. Which one am I using? Well, I'm looking at that right angle. The 5 is the height. What is it associated with? Well, what is it perpendicular to? It's the 14. So I'm doing 14 times 5 and then dividing by 2. 14 times 5 is 70. Divided by 2 is 35 units squared. Okay. Next one. Again, it's a triangle. So 1/2 base times height. So let's find the base. Let's find the height. I look at this and I see that my base, a lot of people are going to put 13. 13 is not the length of a side of a triangle. The triangle is black. It's got black lines there. The red means it's an imaginary line. So that 3 feet there is not part of the triangle. The base is only 10 feet here. The height that goes with it is perpendicular to that. In this case, it's on the outside of the triangle, just like on the front side with the parallelogram. The height is 6. So 1/2 of 10 times 6 is 60 divided by 2, which is 30 feet squared. All right. Last one, a little bit of an application here. The wall of the garage shown below can withstand 7,500 pounds of force. How fast will the wind have to be traveling to knock down the wall to the nearest unit? So there's my formula. F is the force. We know that. That's 7,500. That's what it can withstand. The area of the structure is the big A, and the velocity is what we're looking for. So we don't know that one yet. We're looking for that one. Okay. We need to find the area though. So we have enough information to find the area. The area of the shape is equal to the area of the triangle plus the area of the rectangle. The rectangle should be pretty easy. It's just 12 times 20. So the area of the rectangle, I'm just going to put is 240. If you're not sure, put a question mark there and ask me in class, but it's just length times width or base times height. The triangle is 1/2 base times height. Well, the height is the 6. The base would be this side here, which we should know from opposite side being 20. So the base here is 20. 20 times 6 is 120. Half of that is 60 plus 240 gives me my area, which is 300. So the area of the structure is 300 feet squared. All right. So now I can plug my stuff in. F is 7,500 equals 0.004 times 300 V squared. Well, 300 times 0.004 is 1.2. So 7,500 equals 1.2 V squared. Divide by 1.2. I get 6250 equals V squared. Take the square root. And I get 79.05. or I guess 0.6, but it says round to the nearest unit. Now that rounds to 79 miles per hour, but that 79 miles per hour would not knock down the wall, because that would get you just to 7,500 pounds of force, but not quite there. So the nearest whole number would be 80 miles per hour. An 80 mile per hour gust of wind would knock down that wall, is what that's saying. Okay. So that is areas of parallelograms and triangles. We're going to do Pythagorean theorem with some stuff with that in the next lesson, and then we're going to do a lot more area after that.